So the next one says e to the square root of x over the square root of x from 1 to 4. So because I have e, a lot of times if there's only one e in the expression, its exponent is usually going to be our u. So I'm going to let u be the square root of x because that's what e is raised to. Then when I take the derivative of that, I get 1 over 2 root x dx. So if you thought of this as x to the 1/2, it would be 1/2 x to the negative 1/2, which is the same as this. The reason I prefer this notation is because there's a radical in the problem, and I want to try to match this back as directly as I can. So now I see that I have my square root of x dx, but I don't have my 2. So the substitution I'm going to make is that 2 du is 1 over the square root of x dx. So if we go back up here, right, that's 2 du, and then I can see I'm going to have e to the u in the numerator. The original bounds on x were 1 to 4. So now to change my bounds, remember our original a was 1, and this was x equals 4. So when I plug 1 into my u equation, I get the square root of 1, which is 1. When I plug 4 into this equation, I get the square root of 4, which is 2. So my new integral is 1 to 2 of 2e to the u du. So I can also put the 2 out front. That's probably a little bit better. So there's my 2 times du, there's my e to the u. The antiderivative of this is just 2e to the u, and since I've changed my bounds, I can just simply finish the problem. So 2e squared minus 2e to the 1, so 2e squared minus 2e. Problem 3, well here I want to make my u, I'm going to try making it the denominator. And you can see the denominator is a quadratic, and we know when we take the derivative of this we're going to have something times x, but I have an extra x in the numerator, so this will probably work out for us. So u is going to be the denominator, 25 minus x squared, and du is negative 2x dx. So when I go back to check my integral, well, there's my du right there. So I'm good to go. Now we just need to change our bounds. So the original bounds were from 2 to 4. So when x equals 2, I simply plug 2 in for x to find out my new u. So 25 minus 4 is 21. 25 minus, sorry, this is u equals 4. So 25 minus 16, because I got to square it, gives me 9. So notice here, right, when you go to write these bounds are going to be backwards. Since x equals 2 gave me the 21, it's got to go on the bottom. X equals 4 gave me the 9. And my new equation, when I substitute, is 1 over u du. Now, this is backwards. We want the smaller number to the bigger number. So I'm allowed to reverse those bounds by multiplying everything by -1. Now I'm ready to anti-differentiate. So I get negative ln of u, and we're going to evaluate this from 9 to 21. So it's negative, the natural log, absolute value of 21 is just 21, so I can drop the absolute value bars, minus a minus the natural log of 9. So I can leave it like this, but I just don't like to have negatives in front of the expression. So technically, because this is natural log of something subtracting natural log of something, I could make this even more simplified by writing it like this. So that's something you want to keep in mind if you're ever looking at a problem online, or you're looking at a solution, or you're looking at problems in books. Sometimes your final answer, they may simplify farther than you, but either one of these 3 lines would have been an acceptable answer.